Hello and welcome to our webcast, Condenser Tube Cleaning, Essential for Reliable Power Generation. I'm your host, Sonal Patel, an Associate Editor at Power Magazine. For today's program, we'll hear from Gary E. Fisher, National Sales Manager from Conco Services Corporation. Gary is the National Sales Manager for Conco Services Corporation, which is located in Verona, Pennsylvania. Gary and his team manage sales activities within the U.S. power generation market. Conco Services Corporation is the world leader in offline mechanical tube cleaning. From power generation to polymers, alumina to refineries, Conco technicians have restored efficiency and reliability to over 150 million condenser and heat exchangers tubes worldwide. In addition to cleaning services, Conco is a leading provider of non-destructive testing services, including RFT, eddy current, and tracer gas leak detection. Gary holds a Bachelor of Science degree in Electrical Engineering and also an MBA from the University of Pittsburgh, and is a longstanding member of the American Society of Mechanical Engineers. Gary has served as the organization's program coordinator and past chairman of ASME's Heat Exchanger Committee. He is a frequent presenter at power shows and conferences on subjects relating to cleaning, eddy current testing, and leak detection, and has written several articles for those topics for trade magazines, including Power Magazine. This presentation will last about 45 minutes and will follow with a Q&A portion. Before we get started, I would like to point out a few housekeeping rules. At the left of your screen, there's an area where you can type and submit questions to Gary. Feel free to send in questions at any time during the presentation, and we will try to get them answered during the Q&A portion or by email after the program. If you are experiencing any technical difficulties, you can type that problem in the same area at the left of your screen, and our production staff will assist you. This webcast will be archived on our server for up to a year, and it will remain free of charge. You can use the same URL to reach the archive program as you did to reach the live program. Before we begin, I'd like to thank Conco Services Corporation again for underwriting today's program. Their generosity allows everyone to attend the presentation at no cost. And with that, I'll turn the program over to our speaker, Gary Fisher. Gary?
Thank you, Sonal. I appreciate that. And good morning to everybody. I'd like to welcome you to our webinar on condenser cleaning and the effects fouling has on your condenser and on plant operations. We know that you're awful busy, so we appreciate your time, and we hope that this webinar will help you moving forward with your maintenance on your condenser and answering any questions you have concerning cleaning. So what are we trying to do? We're trying to have a total condenser performance, which is achieving perfect balance of condenser efficiency and reliability. That condenser, that big box of tubes with no moving parts off in the corner, it's often forgotten or neglected. It's a piece of equipment that just sort of operates by itself, and because it's no moving parts, physics takes its role, and physics is what makes the condenser operate. However, when outside forces interact within the condenser itself, it changes the physics and therefore changes its operation, and it then affects your entire plant operation. And it can be an adverse effect if not monitored and taken care of in an efficient manner. So we're going to talk about ways to keep that condenser performance at peak efficiency and reliability, and one of the ways to do it is cleaning. And that's what we're going to focus on today, cleaning. More importantly, we're going to talk about mechanical cleaning. So why do we clean? In many instances, we clean because somebody higher up says, hey, put this into the maintenance schedule and make sure you get those tubes clean. But there are some very significant reasons why we should clean and what we should have in the back of our minds whenever we go into this process. There are financial reasons. There are also reasons to improve the performance of the condenser itself and to improve the performance of the entire process. You want to protect your condenser tubes. In fact, you want to protect the entire condenser. It's a major piece of equipment. You want to make sure that the life of that condenser, which maybe those tubes have been designed to last for 25 or more years, aren't having to be replaced in 15. So you want to make sure you maintain the condenser itself. And surprisingly, you want to protect other pieces of equipment within the process. And how this condenser can affect those pieces, we're going to talk about that. So what are some of your financial reasons? You know, almost everything relates back to finance, but here's some that we can tie to directly. One, heat rate. The lower the heat rate, the lower the fuel consumption. And so that means that your cost of fuel goes down. Now, in many instances, fuel is a pass-on, but you don't want to have to do this all the time. You don't want to have your fuel consumption go up and you constantly try to pass this on to the consumer, watching your rates go up and have the consumer be frustrated watching their rates go up. So you want to make sure that you keep your heat rate in play so that you lower that heat rate, lower your fuel consumption. But another big one to consider is unplanned outages. They can be very expensive, and as you can see, generators lose hundreds of millions of dollars annually to problems that are related to condenser, fouling, corrosion, and tube leaks. There are many times where a condenser fails you in its peak time of usage, July, in the summer months of July and August. That's when the condenser will fail because it's being pushed. You want to make sure that that unplanned outage does not occur. You want to limit those, and one of the ways to do it is by having a good cleaning process. You also have performance issues. What are the performance issues? Well, loss of megawatts. You know, as the condenser performs its tasks and it impacts the overall system reliability, one of the issues you can run into is actually by pushing the unit, you can lose megawatt capacity. And although that megawatt capacity may be at 1 or 2 megawatts at a time, over a period of time, that can add up into big dollars, and that adds to the bottom line of the customer of that plant. So you want to make sure that you keep this unit running at a high performance at all times. Also, you can have an increase of emissions. Now, in today's day and age, when the EPA is very stringent on the emissions, you want to make sure that you don't have any future problems or any problems coming from the fact that you have an increased emissions. And we're putting on carbon capture and we're putting on scrubbers on a lot of the units in order to reduce the emissions. This is an easy way. Cleaning the unit, keeping the unit clean and efficient keeps those emissions low. And you don't want to have a situation where those emissions increase just because you haven't cleaned the unit. You also want to protect your product. You want to protect your piece of equipment. You want to protect that condenser. You want to extend the useful life. And the problem you can have is that when you have fouling, you also trap that fouling mechanisms which interact and cause pitting and cracking and tube erosion under that fouling. So you can have under-deposit corrosion. That affects the tubes. That not only reduces the life of those particular tubes, but it also inhibits the ability of the condenser to perform its task. You also have issues where you have a decrease or a change in water flow. In many instances, and we'll talk about this later on in the process, you run into a situation where you plug those tubes up. And when you plug those tubes, you don't get the good water flow. When you don't have the water flow you need, then you're not being very efficient. You also want to protect other pieces of equipment. And this isn't thought about that often, but you know, a higher back pressure also equals a higher enthalpy, and that means turbine inefficiency. And that turbine, which is the lifeblood of the plant and which is the baby of the plant, when that starts to see inefficiencies, everybody is under the gun. So we want to make sure that the higher back pressure does not affect that turbine efficiency. Higher back pressure also means that you have a hotter and denser steam, and that affects or adds the stress on the turbine blades. More importantly, I believe it's called the LO blades, which are the longest and most delicate blades in the turbine. It puts added stress on those blades, which could cause cracks in the blades themselves and possibly even throwing a blade. So you want to make sure that you keep your back pressure low too, because it will affect the turbine. And if you're not condensing completely, the steam is not being condensed in an effective manner, you also have boiler and condensate issues. So this condenser, this big box with just tubes in it that's sitting over there in the corner, can affect the entire operation and every piece of equipment in the plant. So we want to make sure that we have a cleaning process that works and works efficiently. Now, why are some of the issues? Why do we have these fouling issues, and why sometimes do they get out of hand? Well, in many instances, the engineers and the chemists and maintenance people in the plant underestimate what's actually in the water. You're pulling this water from a lake, maybe from the ocean, from the rivers or a pond, and in many instances we underestimate what is in that particular body of water that you're pulling in and you're flowing through the condenser. By not understanding that, you can estimate that, oh, I'm going to have fouling and may have to clean once a year, maybe every 18 months, when in actuality it's building up much quicker and you should do it on a much more timely basis. So understanding your cooling water chemistry is a key, and then working with your chemical vendor to make sure that you've got a good program to treat that water is also a key in keeping the fouling down within the condenser. Now let's talk about the fouling itself, and we put them into 5 categories. We believe that all fouling will fall into one of these 5. It's deposition or particulate. You can have scaling or crystallization, microbiological fouling, debris and macrofouling, and corrosion products. Now, you will have at least one of these in your condenser, but it's possible that you have more than one. You may have a fouling mechanism that falls within various categories here of the fouling 5, and you have to know what you're up against whenever you do the cleaning process or decide how you're going to go about with your cleaning process. So what I want to do today is go over these to explain them a little bit so that you know what they are and what we are talking about when we talk about these 5 categories. Deposition or particulate fouling. This is particulate debris. It settles on the tube surface. It's usually very moist. It's wet. It's a mud. It's a silt. A lot of times we see it coming from rivers, as maybe the inlet is near the bottom of the river, and so it's pulling from that bottom. Many times it's when you have a low water flow within the river, or the pond is low that you're pulling from, and so now you're pulling more debris. But what happens is that this limits your flow conditions. This gives you low flow through the tubes. Because it's a wet type of fouling, it also greatly impacts your heat rate, and it stimulates your under-deposit corrosion. So it's something that you need to know and you need to get out depending on how much that you have, how much fouling that you have at any particular time. Scaling and crystallization pretty much tells you right up front. What we're talking about here are the irons and are the types of scale that form under temperature and played out within your tubes. Now, scale is very interesting in that sometimes you can have scale in the tubes and not see a heat rate change until the scale gets thicker. Once it becomes thicker, then it becomes a problem. Calcium works in this way. If you have a thin layer of calcium, you may not notice it. You may not see anything that is changing. However, as it grows thicker, it immediately impacts your performance, but by then you've got a real problem on your hands. It also will have under-deposit corrosion. It traps that underneath the scale, and that under-deposit corrosion then begins to interact with the tube's material and eat it away. Microbiological fouling. This can be very insidious. It's a bacteria. It presents its form like a biofoul. It can be under the scale. It could be in the deposition and particulate fouling, or it could be by itself as a growth on the tubes. And what it does is it interacts with this tube, and then it consumes the base metal. In many instances with this type of fouling, you would do an eddy current test and you would see a pit, or what you think is a pit. And if you're not using the proper number of channels on that particular eddy current test, you would not be able to see that what it's really doing is it's eating and consuming that base metal in between the inner and outer diameter of the tubes. So what appears to be a pit is really a small little cavern in there, and it's weakening the tube as it continues to interact with that tube material. the debris and macro fouling. This happens a lot along the oceans, along rivers up here in the north in the fall when we get a lot of the leaves that fall into the river itself. The shells, the leaves, the aquatic life, they somehow get beyond the mechanical screens and they will then plate out against the tube sheet. Sometimes they block the tube completely. Sometimes it just limits the tube and the amount of water, but it changes the physics within the tube, and so you get partial flow, sometimes no flow through certain tubes, and then what happens is you get erosion corrosion at the end of those tubes. If it makes its way down the tube, then what happens is it also traps the fouling and the mechanisms of corrosion underneath, and therefore you get the damage to the tube as far as the pitting and the cracking go. And then you have your corrosion products. The corrosion products go down, eat away the tube. You want to make sure that you remove these. They interact with the tube itself, and they take away the tube material as it develops. Now, we know what your tube surface is. You know what type of tubes that you have, and I want to talk a little bit about that. This is not an indication of what's good or bad. It's just every tube material has its own characteristics, and we want to talk a little bit about those characteristics and what you face. So if we talk about copper alloy tubing, the Admiralty brass, the aluminum brass, the copper nickel type tubes, very good heat rate, very good material, but when you get fouling on these tubes, you're going to have corrosion characteristics such as crevice corrosion and pitting that can easily occur underneath that fouling and interacting with that tube material. Erosion corrosion, when we talked about, they're very susceptible to that, especially if you've got these shells blocking the tubes themselves and you're changing the dynamics as the water enters those tubes in the condenser itself. You also have to worry about the alloying, such as dezincification, and you have to worry about ammonia corrosion on these types of tubes. So if you have copper-based tubing and you know what type of fouling you have, you've got to be aware of the situation that you're going to face as far as characteristics of corrosion. Now let's talk a little bit about stainlesses, and here I'm talking about the 300 series. We see a lot of 304 and 316, so that's what I know a lot about. You run into a lot of crevice corrosion and under-deposit corrosion and pitting on this type of tubing, but stainless also has a very serious issue with the microbiological influence corrosion, what we call a mic attack. It will eat through the tube and it will cause that cavity within the inner and outer walls of the tube and eat away that core of that tube so that it becomes weak and is prepared to crack whenever you put pressure on it, which you're going to do in the summer months. It is also very susceptible to manganese. So if you have manganese in your water, that manganese is going to plate out on the stainless. It's going to interact with the stainless tubing itself, and it's going to cause problems for you in a much quicker manner if you don't get it out. You want to make sure that if you have manganese and if you have stainless tubing, that you remove that manganese and get it out. And then you have your titanium tubing, and titanium tubing seems to be pretty much corrosion resistant, at least from what we see. However, it's still going to impact the heat rate and the back pressure on the unit, and you want to make sure that you remove that and get that out of there in order to have that condenser running at peak efficiency. So now we know what type of fouling that we're talking about, the different types of fouling, and you know the type of tubing you have. So what is it that we've got to look at? What is going to jump out at us to tell us that we've got a problem? Well, there's a variety of different aspects that you can see or listen to as your condenser's talking to you in order to determine what's going on. You can't stick your head in the condenser while it runs, so you've got to read the numbers. You want to take a look at your back pressure deviation. Is that fluctuating? Is that going up? That could be a good indication that, hey, you've got fouling in the tubes. Heat rate, another indication as your heat rate goes up. Cleanliness factor. A lot of plants do have all the instrumentation you need in order to run a very good cleanliness factor program. And if you have that and you have the instrumentation already there, then this is a very good source of information to tell you the status of your tubes. One of the ones that I like is the inlet and outlet cooling water temperature differential. By knowing how your system runs, by knowing the history of your unit, you should be able to take a look at your inlet and outlet water temperature and be able to determine what's happening. Are you having good heat transfer or not? And if you are not, then there's a very good chance you have fouling in the tubes. And of course, the last one is your megawatt. If you're pushing the unit to its maximum and you cannot get it to that peak efficiency, then there's a very good chance that what's happening is you have fouling in the tubes and the condenser is not operating at peak efficiency. So what are we going to do about it? How are we going to get this out? And that's really what we're going to talk about here, how we get the fouling out of the tubes itself. So mechanical cleaning, and this is what we're going to talk about. There are other options, but mechanical cleaning is the one we're familiar with and what we're going to discuss here. So it's the most frequently chosen method of cleaning the tubes, and why it's applicable and it's effective. So you can use it on any type of fouling that you have, picking the proper tool in order to clean that particular fouling out of that tube. It's fast and it's easy to use. And what should be up here in big bold letters is it's safe. It's very safe to use. We use 300 psi, maybe 400 psi of water to project or to propel these projectiles down through the tubing. They exit the opposite side with 100% water. Within a foot, they harmlessly fall to the bottom of the condenser. It's a safe method. You don't have to worry about pressures, high water pressures. You don't have to worry about chemicals. There's no chemical usage, so you don't have to worry about disposing and cleanup after the fact. So it's applicable and effective on every type of fouling that you would have. It's easy and fast, and it is safe. In addition, when it's done, you've improved your heat transfer immediately. So you have a situation where you've cleaned the tubes and the heat transfer immediately improves upon starting the unit up. You've protected your tubes from under-deposit corrosion by removing all the fouling that is in the tubes, and you now have restored full flow through the condenser itself. So you have a way of effectively approaching a cleaning method and effectively cleaning your condenser in a safe, fast, and easy process, which gives you immediate results. Now, how do we do this? So if any of you are out there daydreaming, or you're preoccupied and you're listening with half an ear, here's the part that I want to impress upon you that you should listen to with fervent attention, and that is how to pick the proper cleaner. You see, we run into many instances where we go into plants and they want to do the job the least expensive way. And although that's admirable from a standpoint of keeping costs down, it isn't the most effective way. And so we run into situations where someone says, we shoot nylon bristle brushes in our cleaning process, and we've been doing this forever. And our first question is, but has it been removing everything? Has it been really effective? You got to make sure you want to use the right tool, just like when you're going out to fix a problem with a mechanical piece of equipment. You don't want to take a screwdriver when you need a wrench. You've got to take the proper piece of equipment. The nylon brush, which you see there, which is the blue cleaner, is very effective if you have light silt or light mud in the tubes. It will remove all that silt, all that fouling from the tubes, and it will do a very effective job. But if you have a heavier medium, if you've got some heavy mud in the tubes, or a lot of silt, or scale of any type, that particular product will not work. You've got to go into a metal scraper. The C4S on the far left side is a standard metal scraper that is used for light scale or for a heavy mud. And you want to be able to get that all out. And depending upon how much scale or mud that you have, depending on how tenacious the product is, you then may have to use a more aggressive type cleaner. the C3s, the C2Xs, and 3Xs are more aggressive type cleaners for scale if you have that in your particular condenser. Conversely, if you have manganese, which is very thin and very tenacious and is probably going to plate out right on the tube surface itself, not only will an H brush go over it, but so will a scraper in most instances. So in that instance, a stainless steel tube cleaning brush is what's required. The number of contact points is much greater than that of a scraper, and it literally will go down the tube and remove all the manganese that's plated out within your unit. If you get into a situation where you have calcium and your calcium has built up to where it is thick, you may need to use the Cal Buster and different passes of the Cal Buster in order to remove all that scale. It's critical that you remove all the scale, because if you leave rough surfaces, when you start the unit up, you will begin the fouling process all over again, and the tubes will not remain clean for very long because they'll have something to grow on and attach to that rough tube surface. So you want to make sure you pick the proper cleaner. The best way to do that is to go in and take an analysis. What do I have? When you go into your particular unit, you want to make sure that you take samples. And when you shoot these samples out, you want to be able to catch them. Once you catch that sample, you then want to be able to send it to a lab, either a lab that you have, a lab that you work with, or in our instance, we also have a company that we use for a lab, and you want to get these types of results. You want to know what is in that analysis, what elements are in that fouling, what's in the tube. In this particular instance, you can see that manganese is 10 to 20% of that fouling mechanism. And I'm going to bet that that manganese is plating out right against the tube surface. You also can see that iron, silicon are 5 to 10%, and you've got some calcium, maybe up to 5%. So you've got a scale that's probably sitting on top of that manganese. The aluminum, the potassium, the sulfur, the nickel, they're in there. They're all going to be in whatever water you have, but they really aren't playing a role in your particular situation. In this case, what you're probably looking at is you're probably looking at a manganese that's plated out against the tubing with scale on top, and a very good chance that you may need a two-pass cleaning. You may need to shoot some form of scraper down the tube in order to remove the scale, and then shoot a stainless steel brush to remove the manganese. If the manganese is not there and it's just scale, you may be able to use just one pass of a scraper. And if you don't have any indication of manganese or scale, you should be able to use a brush. So you want to use this kind of information to determine what's in that water. And here's something very critical, and we talked about this in the beginning, what you underestimate. Typically, the body of water you're pulling from is quite large, and so its makeup is going to remain the same as before. However, you have to be aware of other plants or other facilities on that body of water that may be causing it to change its chemical composition. And you want to make sure that you do an elemental analysis on a regular basis so that you are aware of what is going inside your tubes. You also want to be able to take various samples from around the condenser, because the condenser will foul differently in different parts. You'll have a different makeup of the amount of the grams. You'll probably still have the same makeup as far as the elements, but in the steam dump area, you may have a heavier fouling than you would maybe in the air removal section. So you want to be able to take samples around the condenser, because if you only plan on shooting to have 5 grams of mud in your condenser, and you pick the tool to work on that and to clean that, you're missing out on those tubes that may have 95 or 96 grams. So you want to make sure you're under the worst conditions. you understand what you're up against, not only from a standpoint of the elemental analysis, but also from the deposit density. And that helps you choose which type of cleaner you are going to use in order to get a good cleaning. Now, what are the two variables whenever you go to clean? We've talked about a lot of these, the cooling water type in the system that you have, the tube material, the deposit, the corrosion, we've talked about that. But you also want to consider, okay, how am I going to get this done? What's my tube quantity and size? Smaller the tubes, the more impactful the fouling is. So you want to, if you have 7/8 tubes, you may have more of a fouling issue than if you had at 1 1/4. Not that you want to ignore it at 1 1/4, but you want to acknowledge that that's a possibility. You also want to know your schedule. How much time do you have? When can you get into the unit? And do you have a tube cleaning system already on the unit itself? So if you have one on the unit itself, you may have a system that is being helpful in keeping the tubes cleaner for a longer period of time. And so you may be able to buy a little bit of time in between cleanings, not neglecting them, but a little bit of extra time. So how long does it take? We've got our fouling in there, and you're now looking at your schedule, and you're saying, how long does it take to do this particular unit, to clean this unit? Well, there's a various number of factors. One is your fouling type. What do you have in there? If you've just got silt, it's going to be faster than if you're trying to remove scale. So you got to know what type of fouling you have. The number of tubes, of course. Or you've got a 20,000 tube condenser, do you have a 60,000 tube condenser? Are your tubes 35 feet long, or are your tubes 70 feet long? Access to the condenser. Many times we run into plants that don't take this into consideration. But how easy is it to get into the condenser? Do you have scaffolding in the condenser? Is the scaffolding going to impact how you do the cleaning? Is it going to be in the way? Do you have to climb ladders to get into the condenser? So the access to the condenser itself is a factor of how quickly it can be done. Also, your laydown area. How far away is the pump going to be? How far away is the water source? Do I have a big enough water source, or do I need two? And do I need to wide them in? Power. Do I have the power that I need to run the pump and the equipment that I have? These are all factors that you've got to take into play. And then, how are you going to do the unit? In most instances, it's offline. You're in a scheduled outage. You bring the contractor in. The contractor cleans the tubes in, out. Not too many problems, not too many issues that they run into. But there's also the possibility that you're going to do it online. You're trying to improve your condenser performance. You don't want to bring the unit down. You have the capability of valving off sections of the condenser. You can do that. You section a box off, and you can go in and do that work, and it can be done online, but it's going to be done slower because of the heat. With all that said, we can make a pretty good estimate that what you're looking at for a normal crew is about 5,000 tubes in a 12-hour shift. Now, if you have an easier shoot, you may get more than that, up to 6. If you have a tougher shoot where you're trying to get out some heavier duty type of fouling, longer tubes, more difficult to access, you may only do 4,000. But you're looking at about 5,000 tubes on a shift. So if you have a 30,000 tube condenser, you can do some quick math and say, it's going to take me 6 shifts on average to get this done. Maybe 5, maybe 7, but at least it gives you an idea when you're in scheduling. You also want to remember that the cleaner that you choose, regardless of how many tubes you shoot, is going to be effective on all the fouling and corrosion products, the physical obstructions, the tube surface roughness. We're going to get rid of that as long as we pick the proper cleaner. So you don't want to say, listen, I want to increase my speed and make it 6,000 tubes a shift and pick the H brush, knowing full well that you've got deposits that it won't remove. So you've got to be able to determine how long this is going to take and to give you some ballparks. Another question we run into sometimes is the frequency. Most plants say to us, listen, we're going to clean once a year. We're going to clean during our outage, and that's when we're going to do it. That's fine and dandy. It works for a lot of plants, especially if you're doing it in the spring, because you enter the summer months with clean condenser, and you can make it work extremely well, high efficiency and high effectiveness. But sometimes that doesn't work. And what you've got to do for frequency is you've got to determine what best fits your plant. Where do you sit? Where is your water source? Are you pulling from a water source that has heavy minerals in it? Are you pulling from a water source that continually brings in a lot of debris and a lot of shells that you've got to remove? Or are you on a water source that's pretty clean? And if you're on a source that's clean, maybe you don't have to do it every year. Maybe you only have to do it every 18 months. What type of fouling product do you have? What am I looking at? Do I have manganese? If I have manganese and I have 304 stainless, I may want to up my frequency of cleaning in order to make sure that manganese is removed so that I can continue to keep that condenser not only running efficiently and effectively, but also longevity-wise to make sure that those tubes last as long as we hope they do. And that's where the tube material comes in. And then, of course, your maintenance schedule. What's your maintenance schedule? What type of schedule do you have? Do you have the capability of coming down for a few nights or a weekend when you're not in an outage? Can you do that? Is that possible? That all comes into play when you do the frequency. You've got to determine that. You've got to determine what's best for the effectiveness of the condenser and also its longevity. What are the real benefits you're getting here? Well, you're getting an immediate economic benefit. You're going to get an immediate return on investment. You're going to reduce your costs. If we pick the right cleaner, we know what's in those tubes, we know what your schedule is, and you get a good company in there to do the work, you can get and remove the fouling from those tubes, and you can get that immediate return. Any lost megawatts, as soon as the unit comes back on, you should be able to pick those back up. You'll get a fuel savings, a reduction in emissions, which could be a very, very big deal depending on the situation that you are in. And over the long haul, something you don't see immediately, but you extend the useful life of the condenser. One of the things that you really don't want to run into is a situation where you have allowed the fouling mechanism to lay in that tubing and to interact with that metal to a point where that 25-year condenser now has to be retubed in 15 or 16 years. And you've got to go back to management to say, we have got to make a major investment in a couple years in order to retube this condenser, 5, 6, 7 years before we planned on it, all because we did not remove the fouling from the tubes. And we now have so many leakers and so many plugs that the condenser is not effective and efficient. One of the things I do want to bring up on the cleaning side is the plugging. Many times we run into situations where after a cleaning, there are certain tubes that want plugged. In many instances, this is after an eddy current testing also. We recommend for every plant to determine what type of plug they want to purchase and to keep at least 2% of the total tube quantity in stock. The last thing you want to do is have a situation where you need to plug tubes and you say to the contractor, we need these types of plugs, and they have to call and order them, and they won't be in for 1 or 2 days. And you're waiting that time to get the plugs. You want to be able to go to your storeroom, pick the plugs you need, put those plugs in that unit, make sure that it's plugged, and then when you have time, go back and order those plugs and bring them back into your storeroom for you to use at a future date. So in summarizing, and I see that I've moved through here a little quicker than 45 minutes, which means we'll have a little bit extra time. But in summary, the synopsis here is to understand what's going on in your condenser. Understand your water source. Understand what types of fouling and minerals are within that water. Understand the material and what is interfacing between your tube material and the fouling, and how do you get it out. Pick the right cleaner, get into the proper cleaning program, and remove the fouling as quickly as you can and to make the unit as effective as possible. You want to make sure that your cleaning practices give you a competitive advantage. You want to make sure that you've performed it in a proper manner so that the corrosion protection is available to you and you extend the life of your condenser. You want to make sure that you don't run into situations where you're losing megawatts in the middle of summer and have to bring the unit down in order to do a quick cleaning in order to get those megawatts back. You want to make sure you don't have unplanned outages. You do not want tubes to fail. You want to have a good maintenance program on them. And you want to make sure that you select the most effective tube cleaning method based upon your plant's specific site's recommendations and situation. If you do that and you do it on a religious program, you will be able to remove fouling and have an effective condenser performance, which means that your entire plant will be running more effectively and efficiently in the long run. I thank you for your time. I am now open to questions that I can answer for you, and I think probably have 15 or more minutes to do that.
Yeah, great. Gary, we have quite a few very interesting questions. Thank you very much for that presentation. Very interesting. So I think we'll try to answer as many as we can. And for those questions that we can't get to, please reach out to Gary. Also, just as a note, if you want any information from the slides, you will need to reach out to Conco, and we'll send you some information that will provide directions on how you can follow up on that. So as a first question, I think there is a question about, I guess it's a clarification, and they want to know, is it correct that, did you say that if the scale is not removed during cleaning, the remaining scale can seed and accelerate the growth of new scale after the cleaning?
Yes, what happens is that if you do not remove the fouling from the tubes, recognize that as soon as you start the unit back up, the fouling process begins, because whatever in that water is now going through the tubes. The cleaner the tubes, the smoother the tubes, the less that plate or that fouling has to grab onto. So if you don't remove it, you're just going to give it a platform upon which to build faster. I'm not saying it will happen within a week, but instead of maybe having clean tubes for 6 months, you may only have clean tubes for 3 months before that fouling begins to impact again, and it just compounds itself.
Okay, great. We also have quite a few questions about using tube cleaners, and one question is that, could you use more than one tube to get all the fouling off? You know, could you perhaps start with a nylon or move to an aggressive cleaner? Is there a sequence that you recommend? Is there a specific way that you should be using these?
That's a good question. Yes, you can use multiple cleaners. We run into that quite often. And the situation would exist, how would you sequence them? The best way to do it would be to actually come out to the unit and do some test shooting. Use various cleaners, shoot them down various tubes, do it in a specific sequence in order to see exactly what you have and what works best. We have had situations where we run a nylon brush through the tubes in order to remove loose debris. And then we shoot either a scraper or a stainless steel brush in order to remove the manganese or the scale. I think I pointed out in one of my slides there that you can have manganese and scale in a tube, and the manganese plates out against the tube itself. You'll have to use a scraper to get out the scale, and then you want to use a stainless steel brush to get out the manganese. So you really want to do some testing there in order to determine exactly what's the best method. But if you have an analysis, an elemental analysis, we should be able to take a look at that and give you some pretty good suggestions based on past history.
Okay, thank you. Another question I think that has come up is there's quite a bit of concern about damage to the tubes by the scrapers. Has this happened, and can you prevent it?
You've got to be very careful in the cleaners that you select. There's a lot of different types of cleaners out there, and I'm talking metal cleaners, because a nylon brush will not do any damage at all. But you want to make sure that the metal cleaner that you choose is one that has got no sharp edges on it. You want to be able to squeeze the metal cleaner and make sure you don't feel any sharp edges, because a sharp edge will dig into the tubes. Now, I'll speak from our side. Our cleaners are designed with rounded edges so that it does not damage the tubes. And our cleaners we manufacture the cleaner to the specifications of the tubing. And you want to make sure that's the case also. If you have a 1-inch by 22 tube, you don't want a cleaner that's going to self-adjust or one that you have to adjust on site. You want to be able to buy cleaners that show up on site that are 1-inch by 22 and designed for that specific size, so that the metal scraper then is designed not to damage the tube, but to run down the tube and remove the fouling without doing any damage. Tempering of the metal blades also gives it the flexibility as it goes down the tube to move and adjust itself, if you will, in a way that it won't damage the tubes itself. So you want to make sure you've got good temper on those blades. And if you do that and you pick the proper cleaner, you should not do any damage to your tubes. A note of caution: if you have certain materials of tubes, you want to make sure that you're picking the proper cleaner also. A stainless steel tube can handle a much more aggressive type cleaner than a titanium tube. So you want to make sure that, knowing you have titanium, you're picking a cleaner that will remove the fouling but will not damage your tubes. And that's where you've got to go in with a contractor that you rely on, and one that's been in this situation before and is able to tell you, here's what we know we can do, and here's what's going to be effective for you.
Okay, great. A lot of questions that we have about how effective are these methods with, for example, Asiatic clams are an issue with some condensers. So have you had success with using scrapers to remove them?
Yes, we have. I'm going to be upfront. I am not as familiar with the Asiatic clams as compared to another type of clam, but I know that we have had a variety of different situations above in the Great Lakes, along the ocean, and down in the Texas area where we've had clams. If you pick, again, the proper cleaner, they would have to be a metal type cleaner. The nylon brush probably would not work in that situation, but a metal scraper size for your tubing would work, and we would be able to remove those clams from inside the tubes. If you're outside on the tube surface, you would probably have to just scrape those off the inside the condenser itself before shooting the tubes down with a cleaner. But you can be effective in removing them. Yes.
Okay, great. So somebody has asked, the methods that you've talked about are really for straight tubes. Is there a way you can use, is there technology for example, for U-tube heat exchangers?
Yes, there is. We were just talking really condensers here, but we see a lot of U-tubes and heat exchangers. And we do have a U-tube cleaner that will go around the bends. You have to be a little careful. Experience will work. When you get near the center where the bend is so sharp that you cannot get the cleaner, we'd have to take a look at your specific design to tell you how many rows that would be. It may be 2 rows, it may be 4 rows from the center, but you have rotary brushes that we can use on those tubes, but you can shoot U-tube cleaners down a U-tube and clean the bend as well as the straights on heat exchangers. Okay,
and related to that somewhat is, can you use, how effective is it to use a condenser, to use a sponge ball for condenser cleaning? Have you come across that?
Okay, sponge balls are typically what you're using when you have an online cleaning system. And the real purpose of having the online cleaning system is to keep that unit clean longer. As I mentioned, once you start the unit, the fouling process begins. With the ball cleaning system and with those sponge balls going down the tubes, you should be able to remove debris, the loose debris, more effectively and not let it attach to those tubes for a longer period of time. So it's an effective method to elongate the cleanliness of the tubes. But a sponge ball will not clean a tube unless what you have in that tube is a very light type of silt. Otherwise, the sponge ball is not meant as that type of cleaning device. It's meant to elongate the cleaning process to keep them clean longer.
Okay. One of the questions that we've also had is, it has to do with time constraints. If you have a limited window to clean the tubes, is there a better way, or is there a way to focus on what to clean first? How would you go about it if you had a short time just to get it done?
There's a couple things to consider in there. One is how big is the condenser? Can I get more people in there? You can always add more people. When we talk a crew, we talk 3 or 4 people. Can we get 2 crews in? Can we go around the clock? If the condenser's big enough, you can maybe get 4 men inside the condenser, and you can bring extra pumps and extra cleaners, and you can make the process quicker. If not, if you've got a smaller condenser and you've got a very limited time, and you say, listen, I want you to come in and do the best you can in this 1 8-hour, 10-hour, 12-hour time period before we have to bring this unit up, you would come in and from experience take a look at where you're going to foul the most. It would not be the air removal in most instances. It may be on the impingement side. It may be where the steam dump is. So you'd want to take a couple shots from around the condenser before you start in order to make sure you see where the heavy fouling is, and then you would work on that particular area until, of course, the time is up, and then you'd move out.
Okay, thank you. Another question is, here's a clarification. So if the 5,000 to 6,000 tubes per shift that you mentioned, is that based on shooting each tube once or with multiple cleaners?
That'd be once. That'd be once. That'd be loading a cleaner, shooting that particular tube, and then going over and picking the cleaners out from the other side and starting the process again. Let me go a little further and explain how that works. Whenever you do a cleaning, cleaners are meant to be used multiple times. So if you have a scraper, depending on how heavy the scale is, you can use some of those metal scrapers 10 to 12 times. So you load what you have, shoot it through the tubes, go to the opposite end, gather those cleaners, and then go back and start the process again. Under that scenario, shooting 1 tube at a time, you can do about 5,000 tubes, average.
Okay, great. Somebody seeking your advice on what form of cleaning you could recommend for a system that, for example, uses river water with varying levels of salinity for cooling water. What would you tell them?
Well, I would say that you'd probably, if you just said to me, come on in and do that, do a cleaning, my first question would be, what river are you on? Let me give you a quick example. If you're sitting in Pittsburgh, we have 3 rivers. The southern river is the Monongahela. The Monongahela is a muddy bottom river. You're going to get silt in that particular river. If you are on the Allegheny, that's a hard bottom river, and you're probably going to end up with more of a light scale, if you will, rather than a mud. So you got to know what river you're on and what you have in there. But I would either use an H brush or a C4 scraper to come in, and that's what I would use for the cleaning. And then I would learn from that first cleaning what you actually have and what you need to be effective moving forward. And of course, we always involve the plant and the engineer and the chemist or the maintenance person, whoever that person is that's in charge of the condenser. We involve them in the decision, and we show them the results, and then we move from there. But my first inclination would be, if you've just got some mud and silt, maybe we'll get away with an H brush. If you don't, if you're on the Mississippi, we're going to use a C4 scraper.
Very good. Okay, a question here. So a lot of your talk today focused on mechanical cleaning, and you said it was safe, but can you talk a little bit about the risks with, for example, high-pressure water jet tube cleaning?
Yeah, I can talk a little bit. No, I'm not a high-pressure guy, so I can't tell you all the ins and outs of it. But anytime you have a high-pressure water, and you're starting to talk, thousands of PSI, you have got a a safety issue with the personnel. As safe as you want to be, you're trying to clean out 20,000 tubes, 30,000 tubes. You've got to be aware and on your game because that can be a dangerous supposition. You don't want to have that wand exit that tube with anybody nearby and it still be on. That could be a safety issue for a person. You also have to watch, and a lot of this has to do with the experience of the person using the wand. You don't want the wand to go in or out of the ends of the tubes because you can damage that interface, that roll where the tube meets the tube sheet. So you've got to be careful with that also. So those are some of the things you got to worry about when you do high pressure water. Basically safety and that damage. You've got to make sure you have a reputable contractor in order to do that type of work, so that they've got a good safety record for you, or else you could be asking for trouble.
Okay. Gary, would you talk a little bit about the type of proactive tube plugs that are commonly used and why?
Sure. It all depends. There's all different types of tube plugs out there, and it all depends on what the plant wants to do. One is a permanent plug. That's what we call a pin plug. Basically what it is, it's a plug that you put in the tube. You get out your hammer and you hammer that plug in with the intent that you are not going to remove it. That's in there for the life of the condenser. You don't plan on ever removing it until you retube the condenser itself. That's a situation maybe where you have a broken tube. You know the tube has got a hole in it, or you know it's split, you know it's cracked, and you're saying, I'm never going to use this, so you want to permanently plug it. The next type of plug is one where you are just putting it in for a temporary basis. You're saying, listen, I don't have enough time to solve this problem right now. I've got to wait for the next outage. I've got to wait 1 year. I've got to wait for some time period for me to get back in here. So what you're going to do there is you're going to put a temporary plug in, knowing full well that this plug is only going to last a certain amount of time before you have to go in and remove it and repair that particular tube. In many instances, we run into situations, the intentions are great. We put in a temporary plug, but then we forget to go back because it's tough to remember that your initial objective is to drain the swamp whenever you've got alligators snipping at your butt all the time. So you got to be aware of that. The next type of plug is one that's a more permanent plug, but it's removable. So you can go in and you can pick a plug that you're saying there could be a time down the road where technology will be available to repair this particular tube. Maybe it's a small pit that you have in there. Maybe it's got 80% wall loss, and you're saying there could be a time when we can go in and the technology will be to repair it. But I want to do a permanent plug that I'm not going to worry is going to fall out in a year, but that I want to be able to go back in and remove it. And those plugs are all available. You also have the ability to do explosive plugging. That's a permanent plug. So you've got to decide what you really want to do. Is it something you want to make permanent, something you're going to go back and fix within the year, or something that you're saying, listen, I want to put this in and not worry about it, and in 5 years I'll revisit this particular application. And there's a variety of different plugs out there, but that's the primary mode of how you want to pick your plugs.
Thank you. Okay, we have time for just a few more questions. I think one question that's come in, it's a very interesting one, is would you provide more details on how to remove hard scale from the condenser tube?
Yeah, there's a variety of different ways to do this, and it all depends on how thick the scale is. Let's go with calcium. If you have a thick calcium in your tube, you are going to need to use multiple passes of what we call our cal buster, which literally goes down and skewers the calcium, and it flakes off in large pieces of look like sheet that come out of the tube. And you use different sizes of the cal buster, shot multiple times down this tube until you get down to where it's manageable and you can shoot one scraper to remove the remaining calcium. If you have a heavy calcium or a heavy iron in there, you may have to use a very aggressive cleaner, multiple sizes, multiple passes, maybe a smaller cleaner in order to get it to fit in the tube, in order to remove the upper layer of the scale, and then attack the rest of the scale with a cleaner, a metal cleaner that is sized specifically for that tube. So you've got to go in, you've got to take a look at the heavy scale, you've got to shoot some of the tubes, and you literally have to do some research on it and some test shooting in order to get the proper cleaning method for that particular unit.
Okay, I think this would be our final question, but would you recommend that you catch a sample at every cleaning? Is that something that is useful?
Yes, I would. It's simple to do. The crew can do it when they arrive, before they really get going, get rolling. They can go in there and they can catch some samples, catch 3 or 4. It's always a good recommendation to know exactly what's going on within your condenser. Typically, we don't see a lot of changes in your elemental analysis, but if you do, and if something does change, you want to be able to catch it right away so that you're able to adjust and make sure that you remove whatever that fouling is. And so I would recommend that you do that every time you clean.
Okay. Well, thank you very much, Gary. We've approached the end of the program, and I just wanted to note, as some of our audience have been asking, the webcast will be archived on our server for up to a year. And you can use the same URL to reach the archive program as you did to reach the live program. And you can send Gary and the Conco team your unanswered questions. And thank you again to Conco Services Corporation for underwriting today's event. And thank you everyone for attending. We hope you will benefit from today's presentation. Thank you, Gary. Have a great day.
Thank you. Have a good day.
Thank you.